Today we are going to discuss about the problems based upon strings and pulley. See, two masses M1 and M2, they have hanged from a ceiling with the help of a pulley. Light pulley is there and a light string is there. All surfaces are smooth. Main friction force we does not have to consider. Okay. What will be the acceleration and tension? They want the acceleration and tension in the string. They have given that this M1 is mass is greater than M2. So see here, how we are finding the force and how we are applying FBD, free body diagram. Okay. So see, M1, mass M1 has weight M1g which will act always downward. M2 has mass M2g which will act vertically downward. When this mass has M1 is greater than M2, so their net force is unbalanced. That's why M1 has a tendency to move downward. But due to string, if it wants to go downwards, tension will produce at this end. Okay, the direction of tension is always towards the midpoint of the string, and one thing, and second thing, if light string is there, the tension will be same both ends. If tension T is here, light string is there, mass is almost negligible, smooth surface is there, smooth pulley is there, so tension will be same at both ends, and direction is along the string and towards the midpoint of the string. So here midpoint is along this, so tension will produce at both ends same, and direction will be along the string and towards the midpoint of the string. So that's I have shown the tension here. T is tension, light pulley tension will be same at the two ends. See, suppose M1 is greater than M2, unbalanced force, so it has a tendency to move downwards because M1 greater than M2, so same string will be there. So what happen? This will go downward, so this will move upward. So see, this will be the total tension and acceleration I have shown in the figure. So this M1 move will downwards and M2 move will upward. In extensible string, so both acceleration will same. The displacement done by M1, suppose x downwards, so same way. In extensible string is there, the M2 will move same displacement upward. If you are differentiating that displacement, the velocity will be same. Again differentiating, so you can say acceleration will be same. Okay. So this also can explain by constant motion. तो ये कि total length of string will be same. तो वहाँ पे भी हम explain कर लेते हैं कि total string की length same है. तो from fixed pulley, if you have taken this x, this taken y, the x plus y is equal to constant. So by constant relation, you can also see x plus y is equal to length of string. Constant differentiating, you can find acceleration will be same. Only direction of acceleration will be different. It will be downward, so that will be upward. So when we will go for the free body diagram of M1, if you see M1 mass, okay, two forces are acting. One is what? M1g downwards and tension upwards. In free body diagram, we are considering only one body. Okay. Others we are not taking in consideration. Only how many forces are acting and what are the acceleration we can apply here. Newton's second law. So see here, M1g downwards, tension T upwards, and acceleration of this is downward. We have taken this mass M1. The FBD of free body diagram of mass M1. What you have seen, net force, because acceleration is downward, that means net force acting downward. So what will be the net force, net unbalanced force? m1 minus j. Two forces acting opposite side, so that's why there will be difference. m1g minus t, net force acting on mass m1 and acceleration is a, so net unbalanced force is equal to, by Newton's second law, mass into acceleration. Mass is m1 and acceleration is a. This is first equation. Same way, if we take mass m2, so here m2 mass I have taken, m2g acts downward, tension acts upwards, and acceleration is upward. So FBD of free body diagram of mass m2, what happened? Tension upward, weight downward, to net force, see here, acceleration upward, so net force will act upward. So T is greater than m2g. So what will be the net unbalanced force? So that is T minus m2g. T minus m2g. So net unbalanced force by our mass into acceleration. So mass is here m2 into a. So this is the second equation. Solve this equation. Adding what happened? T cancel out. m1g minus m2g is equal to m1a plus m2a. m1 minus m2g is equal to m1 plus m2. I have taken common a. This I have taken left hand side. The m1 minus m2g upon m1 plus m2. This will be the acceleration. The acceleration of the string is m1 minus m2g upon m1 plus m2. So this will be the acceleration. If you want to find tension, to put the acceleration in second equation or first equation, you can get tension. If you are putting here, to T minus m2g, T minus m2g is equal to what? m2a. A is what? m1 minus m2 upon m1 plus m2, that is g. So simplify. If you simplify, what happened? To T is equal to m2, you will take right hand side, so m2g plus here m2g bracket m1 minus m2 upon m1 plus m2. Here you can see m2g I have taken common. When m2g will take common, I am writing here, and simplify. So this will come m1 plus m2, m2 cancel. This will come 2m1. So 2m1 upon m1 plus m2. You can see here, what will be the tension? The tension will be 2m1 m2g upon m1 plus m2. So this will be the tension along the string, and this will be the acceleration m1 minus m2 into g upon m1 plus m2. So by this method, by free body diagram method, we can find acceleration and tension. See, we have taken 3 kg and 7 kg, two masses hanged with the ceiling, and a light pulley is there, okay, and light string is there. All surfaces are smooth. So what will be the tension and acceleration? Okay, G, suppose I have considered, we have considered G is equal to 10 meter per second square. See, I have told earlier, the weight of mass 7, that is 7g, it will act downward, tension here T upward along the string towards the midpoint, here 3g weight, same tension will produce on this end point, this tension also upward. If you want to find tension here, so what happened? T and T. So the reverse order they will be here tension, here tension. So you can say here tension will be 2T. If anyone asked what will be the tension at ceiling, so you can also see here tension will be 2T. So this is, I have drawn the forces. See, 7 kg is more than 3 kg. So acceleration is downwards 7g due to more weight. 7g go downward, and by constant principle we can say take a 3 kg will go upward. The same thing is there and inextable. So what will be the displacement here downward? So 3 kg has displacement upward. So same velocity will be there and same acceleration will be there. Only they are opposite sign. It downwards, so this should be upwards. So see here, when we will see the free body diagram of 7 kg. So as previously we have seen, okay, when we will go for the 7 kg, what we have seen, 7g downward, tension upward, and acceleration is downward. So what will be the equation? Net force will be 7g minus T is equal to 7a. With the help of free body diagram of 7 kg, what we have seen? The equation has come 7g minus T is equal to 7a. Same way, when we will see 3 kg mass, 3 kg to 3g downward, tension is upward and acceleration upward. This mean net force will be T is more than 3g. So net force is equal to what? For 3g, 3 kg, if we'll see what happened, net force T upward to 3 minus Tg is equal to 3a. Net force is equal to mass into acceleration, net unbalanced force. So T is equal to what? 3 minus 3g is equal to 3a. Solve this. If you are adding to tension is, it will be cancel out, plus minus, to 7g minus 3g is equal to 7a plus 3a. 7g minus 3g, that is 4g is equal to 10a. If you are putting g is equal to 10, so 4 into 10 is equal to 10a. So 10 cancel out. You can see here a is equal to 4 meter per second square. So we have found that the acceleration is 4 meter per second square. What about the tension? So T is from equation 2. You can see here T minus 3 G, I have put at 10, is equal to 3a. T minus 30 is equal to 3a is 4, which implies that T is equal to 30. We have taken right. So 12 plus 30, that is 42 Newton. So this will be the acceleration and that is the tension. So why we can use directly acceleration, we can find directly also. Net force upon the system divided by total mass, or you can use formula m1 minus m2g upon m1 plus m2. By direct formula we can also find the tension, acceleration and tension. I have told you in previous question, m1 minus g upon m1 plus m2. m1 greater mass, m1 minus mg means 7 minus 3. 7 minus 3 into g command 10 upon 7 plus 3. So that is 10 cancel, a is equal to 4 meter per second square. So from here we can find easily, take what will be there, and also we can apply the formula of tension, 2 m1 m2 g upon m1 plus m2. So what will be the tension? So tension will be T is equal to 2 m1 m2 into g divided by m1 plus m2. Okay. So here you can see this will come 42. Also we can apply tension. I have given the formula tension in two mass system. What will be the formula I have given? T is equal to 2 m1 m2 g upon m1 plus m2. By that formula m1 m2 we have put it, and we have put it the value of g. So we can find this directly by formula also, but it is better that you will go through the this system, because if there is any twist you can handle it. So go through by proofing or by proper method you can find the tension and acceleration of strings or masses in string mass system. See, in this problem, two masses 7 kg and 3 kg, they have suspended from pulley, but here 7 kg is put it on a smooth horizontal surface, and 3 kg is hanged with the help of light string. What will be the acceleration and tension? All surfaces are smooth and light pulley is there. Okay. So how we will find the acceleration and tension? See, so what we have told, the weight always acts towards downward. Here weight of 3 kg, that is 3 g at downwards. So then this system has a tendency to go downward. Let its acceleration is a. So here at this end tension will be produced. The direction of tension will be along the string towards the midpoint of the string. So that will be upward here. If light string is there, mass is almost negligible, inextensible string, and light pulley is there. See here, if light pulley, tension will be same both side. If pulley is not light, in another problems we will show, then tension will be different. So what happen at this end, tension will be T towards this. See, due to tension, what 7 kg has a tendency to go towards right hand side or towards 3 kg mass. So what will be the weight here? Weight of this 7 kg mass, 7 g, but this is kept on the horizontal table. So it will give normal reaction, and this normal reaction will balance this 7 g weight. If this surface, horizontal surface, cannot give sufficient normal reaction, what happen? This surface will be break, it will go downward. We have to keep on a horizontal surface which can be give the sufficient normal reaction to this object. So see here, if we see here, so two forces, normal reaction and 7 g, vertical forces, so they will balance each other. Only horizontal force T will act as a unbalanced force. So when free body diagram of this 7 kg, what happen? Here 7 g, here normal reaction, and one is tension. This normal reaction N balanced by 7 g, only net force unbalanced force, tension is acting towards right, and acceleration, see here same way, acceleration is downward. So by you can say constant principle, what happened, okay, acceleration, same string will be there. What will be the displacement? 3 kg is downward, same displacement will be, inextensible string is there and attached to 7 kg, so same displacement will be towards the right hand side. So what happens, same acceleration will be produced to 7 kg, magnitude of acceleration will be same, only direction is along here horizontal, here along vertical. So here acceleration of this body is A. You can see normally axle is balanced by 7g, so net unbalanced force, so FBD, we have taken FBD of 7 kg mass. So one normally action is equal to 7g first, second one is what, net unbalanced force is equal to mass into acceleration. So only unbalanced force is T by Newton's second law. So T is equal to what, 7 into A. Net unbalanced force is equal to acceleration and tension, same direction. T is equal to 7A. This is for FBD of 7 kg. If you go FBD free body diagram of 3 kg, so see here for 3 kg what happened, how many forces are acting, 3 kg, 3g weight downwards, tension upward, and it has tendency to go downwards. The net force FBD of 3 kg mass, here FBD of 3 kg mass we have shown. What happened, 3g minus T, 3g net force, 3g is more than tension, then acceleration will be downward, 3g minus T is equal to 3a. Mass into acceleration, this is equation 3. Put T is equal to 7, putting T from equation 2 to equation 3. So 3g minus 7a is equal to 3a, 3a plus 7a, that is 10a, g I have taken 10. So a is equal to 3 meter per second. This will be the acceleration. A is equal to 3 meter per second square. And what is the tension? From equation 2, T is equal to 7a, A is 3, so that is 21 Newton. So for this question what we have seen, the acceleration is 3 meter per second square and tension is 21 Newton.